Hey guys, I'm going to be talking today a little bit about graphing exponential functions. This should be review. It's never one of your guys' favorite topics, so I'm going to see what I can do about making it a little bit clearer. We're going to start with this purple one. This is the parent function for anything that involves a base of 2. So you can kind of see I'm going to be graphing these other 3. They all have a base of 2 as well, but they've been shifted in some way from the purple one. So in order to graph this purple one, I'm going to make a small XY chart, right? Just a very small one. I'm going to plug in, let's say, -3, -2, -1, 0, 1, 2, and 3. So I can get some detail. I can see what this looks like. Once I know where it lies, I should be able to graph the other 3 fairly easily. So when I raise 2 to the -3rd power, I get 1/8. When I get 2 to the -2, I have 1/4. This would be 1/2. This is 1, 2, 4, and 8. All right, so really what I have there is 7 ordered pairs. Let me see if I can plot them fairly quickly. One is 2, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you've seen exponential functions before. They are asymptotic, meaning it comes very, very close to this x-axis, but it never crosses it. And they have a y-intercept of 1. Okay, in fact, the majority of these are going to look very similar. Okay, so take a look at the red one next. When there's a negative in front of the exponent, this is going to reflect it over the y-axis. Reflect over the y. Now, if there was a negative out in front, that would reflect over the x-axis. But because this negative is on the exponent, it's going to reflect over the y. So all these ordered pairs that I have, I just have to count to the y-axis and count the same number in the opposite direction. 2 over 2 over 1. They share this point. So again, in red, here is this exponential function. This one's actually more decay, but it's still asymptotic to the x-axis. It gets very, very close, but it's never, ever going to cross it. Okay, so take a look at the blue one. This +3 is on the exponent. This is a change to the x values. It's going to move to the left 3. Okay, it's left 3 from the original, this purple one that's over here. So left 3. So this one is now here. This one is here. Again, I'm just taking every single one and moving them left 3. 1, 2, 3. Okay, so feel free to graph yours on the same graph, right? You can it's easier to count when you see the original one. Okay, so take a look at this green one. This y value, this 3 actually I should say, is being added to the entire function. This is going to move it up 3. The original one, the purple one, up 3. 1, 2, 3. 1, 2, 3. 1, 2. Notice when it moves up 3 how your y-intercept changes. 1, 2, 3. And it's no longer asymptotic to the x-axis. It's now, the asymptote would be here. Okay, that's for the green one. If I asked you what is that asymptote, you would say, oh, that's at y = 3, asymptote. Okay, so that's how the graphs are going to look. You can do 4 on a single graph. I do know for the homework, because I've already done it, you'll have to rescale your graph. You may not be able to count by ones, okay? But make it nice and neat, use a straight edge, make sure I can see the parent graph. Okay, next. The next concept in the lesson is you need to be able to use your graphing calculator. So we're going to do y = 2/3 to the x. And our goal is we're going to construct a table. And find the asymptote. Okay, so it's going to look something like this in your book. So let me break out the graphing calculator. Let's type in 2 divided by 3 raised to the x, right? 2/3 raised to the x. And if you graph it, we should get pretty nice looking picture. And from the picture, you can see that it's asymptotic to the x-axis. But I want you to see what it looks like in the table. So let's see what, I don't even know what my table settings are at right now. Oh, this is actually not too bad. Let me zoom in on them a bit. So you're going to copy this down on your paper, right? Copy down the table. But you can see as the x's are getting bigger and bigger and bigger and bigger, these numbers are they're getting smaller, right? Smaller and smaller and smaller, and you can keep going down the table. All right, those numbers are getting smaller, smaller, smaller. They are approaching 0, right? Now we're in scientific notation. Again, getting closer and closer and closer to 0. We're just never going to get there. So if I asked you to construct the table, you could write that down, right? Write down an x, write down a y, start writing some numbers. And as far as the asymptote, you would say it's y equals 0. Oh, and you can't see what I wrote. There you go. Okay, so you'd have a table here, right? Maybe from -2, -1, 0, 1, and 2, and on, however long it takes to really show that these numbers that you're going to copy out of your calculator are approaching 0. Okay, next, again, these two things should be reviewed, but let me zoom out. I won't leave them on the screen very long because you can always pause. And I don't want to take up all my recording space. So here's continuous compound interest. Feel free to pause. And this is regular compound interest. Again, feel free to pause as necessary. Okay, so now that you've got the formulas, let's do a problem. The problem is, suppose you have $1,000 that you want to invest. And there's two different options. So let me write what your options are as far as investing. One of them would be 5% compounded quarterly. In other words, 4 times a year. That's option 1. Option 2 is you can invest at 5% compounded continuously. Okay, those are your two options. So we're going to compute both of them and see which one is the better deal. All right, so compounded quarterly, I need the formula that looks like this. A equals P times 1 plus R over N to the NT. A is my final amount. P is my initial principal, which is 1,000. 1 plus the rate is the percentage as a decimal, so 0.05. N is the number of times it's compounded per year. So for this example, that would be a 4. And then I'm raising that to 4 times T, which I forgot to mention. I want to figure out how much this is going to earn me in 10 years. I don't want to re-record this whole video, so please just pretend that that was already there. So I'm going to put a 10 right here for 10 years. Okay, this is where your calculator comes in. So let's see if I can punch some of those numbers in. 1 plus 0.05 divided by 4. So that's the stuff that's in the parentheses. And I'm raising that to the 40th power, right? Because you can multiply. And then that's times your initial amount that you plugged in. So after 10 years, I should have $1,643.62. Okay, now let's compare that to what happens if I invest compounded continuously. Again, still for 10 years. Different formula. So I want to figure out what my final amount is going to be after I invest my initial amount. E is a constant. My rate is still 5% and the time is still 10 years. Okay, now if you don't remember, E is it's the inverse of the natural log. Okay, so if you're looking here,